Hi, hello everyone. My name is Jonathan Katz. So in the Postgres community, we talk about wearing different hats when we're representing different roles. So today I'll be representing, I'm representing AWS in this talk, in addition to being a conference organizer for PGConf NYC. But instead of wearing a different hat, I'm gonna wear a different shirt for the time being. So I'm Jonathan Katz. I'm a principal product manager at Amazon Web Services, and I'm giving this keynote on behalf of them. I'm very excited to be here in person. It's great to be back to in-person conferences again. And on behalf of the AWS team, I want to say welcome to PGConf NYC 2022. So AWS is very excited to be participating in this year's conference. We have a handful of talks from other folks from AWS giving presentations over the next couple of days. You can read them off on this slide. Some of these sessions include how to build a hacking toolkit on Postgres, how to manage a database that you took over from someone else, how sharding works, why Postgres is becoming the standard in financial services, how to shard Postgres using foreign data wrappers, and we also have a few other sessions on Amazon RDS's new deployment option, Amazon RDS multi-AZ that gives you 2 readable standbys. This new feature provides 2 times faster transaction commit latency, failovers that are typically under 35 seconds, and additional read capacity. We also have a deep dive session on our Postgres-compatible service, Amazon Aurora. We know that you have a jam-packed schedule of great conference talks, and we hope you can make some time to see these over the next few days. Now, I've also noticed, through the years, my vision has decreased a little bit, so I'm taking a moment to adjust being able to read off my slides. So now, let's talk about open source. By its very nature, open source requires collaboration. Developers build software and make it available for users to build things. Users then build their applications with open source and make suggestions on how to improve the software or even contribute back themselves. As an open source project grows, vendors may start providing support services or products around open source and help contribute to the development of the project. A healthy open source ecosystem has developers, users, and vendors working together to enhance the open source project. This creates a positive, self-perpetuating cycle that helps ensure the continuity of open source. At AWS, we like to call this a flywheel. This is why collaboration is a requirement in open source, because it helps to build and sustain the project through the years, much as we see with Postgres. So Postgres is one of the most successful open source projects, and I believe a lot of folks in this room agree with that statement. That's why we're here. But how did it get this way? As Bruce mentioned in his talk, Postgres is an old project. It started as an academic project at the UC Berkeley in 1986 as part of an experiment to create something called an object relational database system. And while SQL itself had been around since the 70s, it actually was not standardized until 1986. Postgres initially had its own implementation of SQL called Quell. But in 1995, 2 graduate students at Berkeley added support for the standard SQL language. In 1996, Postgres was open sourced. And since then, the development community continued to build on the SQL standard and added many features that made it possible for users to run critical database workloads and added a lot more features to help build out robust applications. This includes support for innovative data types and efficient search mechanisms for a lot of different data types. Some of my favorites being datetime support, range types, which is definitely one of my favorites. In fact, built a very robust application around that. JSON's hugely popular in Postgres, and geometries. There's also something called the procedural language loader. It allows developers to write database code in their preferred language. I love writing procedural language functions in Python, for instance. There's also something called the extension framework that allows you to add more capabilities to Postgres without having to change the core software. So think about that. You can extend Postgres and just install a software package within Postgres and suddenly have a lot more functionality in it. For example, PostGIS, which is an open source geospatial library, gives you this rich geospatial database within Postgres, and all you have to do is create extension PostGIS, and install the dependencies for it as well. These are among the many reasons why Amazon launched both Amazon RDS for Postgres and Amazon Aurora with Postgres compatibility, because we saw that developers really liked building applications around Postgres, given all the rich features that are around it. So what has helped Postgres to sustain its success through the years? There's a lot of reasons, but I'll try to distill it down to 3. For one thing, the Postgres community listens to its users, collecting feedback, learning about their use cases, and using those insights to build an even better database system. The Postgres community also builds openly and collaboratively. Postgres developers discuss designs and challenges in public, work with each other to build towards the best possible solution. Also, many people and organizations in the Postgres community work with community members to support growth efforts and bring in more contributors each year. So let's look at these a little bit more in depth. So first, listening to users. This is very important. If you don't listen to users, you don't know how they're using the software, and you can't necessarily make it better for them. So I think a good example of this was data replication in Postgres. Many of you are using Postgres streaming replication features today, asynchronous replication, synchronous replication, logical replication. But the first support for native streaming replication wasn't added until Postgres 9.0, which was about 10 years ago. Prior to this, to replicate data in Postgres, you had to use external tools. And these external tools were very good, but users still wanted to have a native replication solution. They figured that this would be a reliable, easy to manage, and performant way to be able to transfer data from one Postgres instance to another. The community ultimately adopted this approach, and this has led to many of the replication features that you know and use today. At AWS, we also strongly believe in listening to users to help deliver a better experience. For example, we've had customers tell us that they want to see continued performance improvements in Postgres in each release. I think all of us want to see continued performance improvements in Postgres in each release as well. However, from this insight, one of our engineers reviewed some previous community research, seeing that Postgres was not yet using some modern CPU instructions, the CPU SIMD capabilities. These capabilities can provide speedups on workloads, particularly with many concurrent users. So working with other community members, our engineer proposed a series of improvements that can use these hardware features on both Intel and ARM-based chips, such as the AWS Graviton processor, to accelerate these workloads. These features were ultimately iterated on through the community and were committed recently and are planned for the Postgres 16 release next year, assuming they get through the beta process, but that's why we say they're planned for the release. These features are great. It helps not only our customers, but everyone using Postgres on modern hardware. So let's look into the next insight, building openly and collaboratively. This is the fundamental thing of open source, and it's a big reason why Postgres has its reputation of stability and robustness. You see this every day in the Postgres mailing list, with contributors actively debating. And I will emphasize actively debating. If you get into one of the hackers mailing list discussions, be prepared for a very lively debate, especially on the one-line patches. Those are the ones that get a lot of feedback. But through these active debates, we develop designs and implementations to try to deliver optimal solutions for Postgres users. And that's the ultimate goal, that the Postgres community wants to deliver the best possible product for everyone to use. This extends to the commercial parts of open source as well. Vendors in the same open source project often see similar patterns that can benefit users of every user in the open source project in addition to their customers. So for example, AWS and Fujitsu have heard their customers asking for enhancements to logical replication in Postgres. Bruce mentioned earlier in his talk that Fujitsu has been a longtime contributor to Postgres, so they have certainly seen a lot of different use cases throughout its history. And both of our organizations saw that our customers wanted to be able to do more, support more types of applications through logical replication. So we've been collaborating together, AWS and Fujitsu, on adding data definition language statements like a create table, hopefully for an upcoming Postgres release. Our engineering teams have been working together on building out this functionality, and hopefully, the day that's committed, it's going to be able to benefit anyone who wants to use this feature. So this brings us to supporting community building efforts, the third thing that helps to sustain the Postgres community. There are many ways to grow an open source community, from developing new technical contributors, providing infrastructure for community projects such as testing, and supporting education initiatives through events, kind of like PGConf NYC. The Postgres community has many different organizations involved in growing the community, focusing on all these different aspects. These include vendors who support contributors to work on improving Postgres. There are also nonprofits that focus on building the community through collaborative education efforts, such as the United States Postgres Association, which is hosting the event that we're at today. AWS is certainly very happy to be here and support educational events and sponsor and participate in PGConf NYC, as well as helping to support the continued development of Postgres. Open source projects succeed when people contribute to them. This is the key. It's not just open source is there and you can use it. No, people have to be involved. People need to use it. People need to build it. People need to help maintain it. All these technologies in this slide are ones that AWS directly supports. Much like Postgres, AWS wants to help these projects and technologies by providing customer insights on how open source is used, build and collaborate openly with other project maintainers, and help support the greater open source communities. Did you know that Amazon has actually made a very big bet on Postgres itself? Many Amazon.com systems use Postgres for data management. As Postgres' popularity continues to accelerate, and again, something that Bruce had discussed in his previous talk, Postgres adoption is accelerating, we want to make sure that we can help sustain and grow the project. Through gathering insights from users on how they want to innovate their applications and manage their ever-increasing amounts of data that they're managing, we can build openly and collaborate on enhancing Postgres, grow the contributor community, and bring more users to Postgres. So how does AWS provide Postgres users the ability to run their workloads? Well, we have Amazon RDS, including Amazon Aurora with Postgres compatibility and Amazon RDS for Postgres. So just a brief overview of both offerings. These are our managed services. As mentioned, well, Amazon RDS itself launched in 2009. We launched Amazon RDS for Postgres a little bit later. But customers can benefit from over a decade of proven operational expertise, security best practices, and innovation for cloud-native databases. As a managed database, Amazon RDS helps to remove inefficient and time-consuming database administration tasks without needing to provision infrastructure or maintain software. Amazon RDS offers you the ability to customize your managed workload for high availability and the durability that you need. So Amazon Aurora is our relational database service that combines the speed and availability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases. Amazon Aurora automates time-consuming administration tasks like hardware provisioning, database setup, patching, and backups, while providing the security, availability, and reliability of commercial databases at 1/10 the cost. If you want to learn more about what's new in Amazon RDS for Postgres and Amazon Aurora, please join the talks that I mentioned at the beginning of the slides, or stop by the booth and talk to us, to any of the members of the database team. So with that said, if you're interested in joining AWS and creating better experiences for the Postgres community, want to learn more about our other services, or just provide our team with insights on how we can better contribute to the Postgres community, please make sure to stop by our booth and chat with us. Thank you again for your time, and I look forward to speaking with you more over the next couple of days, both on behalf of AWS, but also as a Postgres community member and conference organizer. And now I am going to change hats, and well, really I'm going to change my shirt and return to my role as a conference organizer. Thank you so much.